Salt fingers, a phenomenon caused by double diffusion. Presented by Group 2 from the Heat and Mass Transfer class at the University of Michigan, 2014. Let's start with the basic concept of diffusion. So what is diffusion? It arises due to the presence of a concentration gradient where mass transfers from a high concentration to a lower concentration, just like how you smell your mom's perfume from across the room. This is the governing equation of mass transfer, showing the relationship between rate of accumulation, rate of production, and gradient of flux. But we don't need to get into too much detail about this for now. Let's move on to heat transfer. There are three types of heat transfer: radiation, convection, and conduction. We all know that heat is transferred from warmer objects to cooler objects. This is why you feel so cold outside in Michigan winters. This is the governing equation for heat transfer. We use this in class, but we don't need to get into the details of it right now. Let's talk about what will happen if both driving forces are acting in opposite directions on a single medium. Let's start our experiment. First, we need some materials. We need a sponge, food coloring, salt, ice, spoon, and a transparent container. You'll also need some way to get hot water. The first experiment is isotonic diffusion. Isotonic means that there is no concentration gradient, so for us it means there's no salt, just cold water and hot water. Let's set up the experiment. We add ice to get really cold water, and then we stir it because we need to make sure that there will be no ice at the time we start the experiment. Next, prepare the hot boiling water. Add 10 drops of food coloring to half a cup of the hot water. Place a sponge on the top of the cold water and slowly pour the prepared solution and observe what happens. Notice that the hot solution floats on top of the cold. This is because cold water is denser than hot water, which is why hot water has a tendency to rise in cold water. Our second experiment is isothermal diffusion. Isothermal means there is no temperature gradient. In our experiment, we will find out what happens if you pour cold salty water on top of cold fresh water. Now let's set up the experiment. Add 10 drops of food coloring to half a cup of cold water. Next, add a pinch of salt to the mixture and stir it until the salt completely dissolves. Now place the sponge in a container of cold fresh water and pour your solution on top. What happens? Look at how the salty mixture immediately sinks to the bottom. This is because salty water is denser than fresh water, so has a tendency to diffuse downward. Our final experiment is double diffusion, where we have both heat and mass transfer gradients. What will happen when we pour hot salty water on top of cold fresh water? This Michigan guy wants to find out. So this time, in order to make both temperature and concentration gradients, we're using hot salty water. Add food coloring and a pinch of salt to half a cup of hot water. Stir until salt is dissolved. Next, place a sponge in the container and slowly pour the hot salty mixture on top. Watch and observe the double diffusion. Here you can see the formation of salt fingers. This is a close-up picture of what ideal salt fingers look like. Here we can clearly see the difference between the three experiments. By understanding these basic concepts of heat and mass transfer, you can understand phenomena that occur in the world around you. Salt fingers often occur in the ocean when water evaporates off the top, creating a warmer, salty layer. These naturally occurring salt fingers might affect aquatic life. We hope you enjoyed our video and learned something today.